Okay, so this is number 3 on discussion 3, I think on page 18. And it says, how many moles of ammonia will be produced if 1.4 moles of hydrogen react according to the following equation? Okay, I can't get this thing lined up, so we'll just have to do the best we can. All right. Okay, so pen. All right, so the first thing that we need to do is balance the equation. Okay, so over here I have N and H, and I have 2 of each. Okay, and over here I have 1 and 3. Okay. Since I see the hydrogens as a 2 and a 3, it's likely going to turn into a 6. Okay, so I'm going to put a 2 up here. So now I have 2 N's and 6 H's over here. Okay, which means I'm going to need 6 hydrogens here. Okay, and I already have 2 nitrogens, so that's good. Okay, so I'm going to put a 1 here just as a placeholder so I know it's 1, 3, 2 for the balancing. Okay, the molar mass, okay, N2 is going to be 2 N's. Okay, and an N is like 14.01, so that's going to be 28.02. Remember, molar mass is grams per mole. Okay, hydrogen, I have an H2, so there's going to be 2 times 1.01, so that's 2.02 grams per mole. Okay, here's something a lot of people messed up on the test. This doesn't matter to the molar mass. Okay, the molar mass is just of H2. It doesn't matter how many there are. Okay, so don't get confused. The coefficient shouldn't be involved in this. Okay, and this should be an N at 14.01 and 3 hydrogens at 3.03. All right, 14.01. I'm just doing this in my head. So this is going to be about 17.04 grams per mole. Okay, again, it's not times 2 because of the coefficient. It just is what it is. Okay. All right, so my particle diagrams, I have 1 and 2 that's stuck together. Okay, I should have 3 H2s that are separated for a total of 6 hydrogens. Okay, and then over here, I have an NH3, H, 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 and then I have another NH3 over here, H, H, H. Okay, all right. Now, the ratios, this is the super important step. I'm going to have 1 mole of N2 and 3 moles of H2, okay, make 2 moles of NH3, okay? This is the important step that I need here, which is this ratio step, all right? That's what I need to know. Okay, so now I'm going to have to scroll, which is sort of annoying. Oh, it's not annoying. It stays right there. That's awesome. Okay, all right, so now we're going to do the Bca table, okay? So remember, B is before, so it says how many moles of ammonia will be produced if 1.4 moles of hydrogen react according to the equation, okay? So for hydrogen, I'm going to have here, my before, I'm going to have 1.4 moles of H2, okay? It says it's going to react, so I'm going to assume it's going to react completely to leave me with nothing. Okay, when I start, I have no product, okay, and I have some other reactant in the form of N2, all right, but I don't really know how much it is. So the key is this change phase. So every time in the change, I'm going to have 1.4 moles of H2 and 1.4 moles of H2, okay? These numbers need to stay the same. Do you see how this is all starting with the same thing? Okay, but it's not a 1-to-1 ratio, right? If it was, we'd be finished. But for the H2, okay, every time I use 3 H2s, I'm only going to be using 1 N2, right? So I have to set up this ratio so my H2 is on the top and bottom and it cancels. Okay, so then I'm going to have 1/3 of 0.14, and I'm going to assume I'll run that out too, because we're going to assume everything is perfect, even though of course it's not, but we'll get to that later. Okay, so then I'm going to have 1.4 basically divided by 3, so I'm going to start with 0.47 moles here, okay? Right, the key is this ratio right here, all right? On the product side, I start also with 1.4 H2s, and I know every time there are 3 H2s that I use, I'm getting 2 NH3s out of that, all right? So the H2s are going to cancel. So now I'm going to get basically 2/3 of that, okay, or 0.093 moles NH3. Okay. All right. So the key to doing this is in this middle step here. This is where all the ratioing is happening in the change. I'm starting with the given, and then I'm multiplying by the ratio. Okay. So I'm going to need 0.47 moles of N2 if I'm going to want to use 1.4 moles of H2, and then I'm going to get 0.93 moles of NH3. Okay. All right, let's see if I can scroll this any further. No, not really. Okay. All right, now dimensional analysis. Can I squeeze it down here maybe? Okay. And when I use dimensional analysis, this is actually a lot simpler, but I want to make sure you do all these other steps because I want you to understand it. Okay. So I want to know how many moles of ammonia will be produced. Okay, so I already see here is going to be my answer. Why is this not working? Yep, there it goes. Okay, so basically the dimensional analysis is doing this change step. Okay, so I know that I started with 1.4 moles of H2. Okay, and then the ratio is for every 3 moles of H2, I know I'm getting 2 moles of NH3. Okay, those moles of hydrogen are going to cancel, and you see that's how I got this number here, moles NH3. Okay, and that's what it means by using dimensional analysis. You already are using dimensional analysis here, right? But when they say just use dimensional analysis, it's just doing that step. Okay, so to me, this is kind of like the cheat way to do it. It's just easy and fast, but I want you to really understand where all of it comes from. Okay, all right, so that's that one, and I'll make some more.